Next one. Common collector. Identify schematic symbol. How do you know? Well, that positive BCC should give it away. Doesn't look like the other two. That should give it away right there. Input's still on the base. Now it's with respect to the collector. Because the collector is tied to the positive potential or positive of the power supply or the DC source. Still on the base. Where's the output now? Must be the emitter. All you got to do as far as the inputs and outputs, look at the little circles there. I should tell you right there, oh, those are inputs and outputs. And the input's always going to be from the left, isn't it? Output's always going to be from the right. Wow, amazing. What's the phase relationship from the input to the output?
In phase.
That's going to be in phase. In phase. No shift this time. Current gain. Where's the output? It's on the emitter. How much current's there? 100%, right? Yes, 100% current on the emitter. Could you say very high?
Yes, sir.
Sure can. Also, what else could you state about that? Huh? Yeah, it's higher than transistor beta. Because transistor beta is a relationship between the base collector. If I'm taking my output at the emitter, well, it's 100% higher than basically this 95 gas, higher than beta. What about the voltage gain?
No.
Output's at the emitter. How much opposition is going to be there? Not very much. Low. And again, the emitter. What did I say about the emitter? When it has to do with impedance and voltage gains. With the emitter, it's always going to be low. Power gain, very high times low. What could we say about power gain?
High.
We could say high. Input impedance, it's on the base, so it must be
High.
high. Output impedance, it's on the emitter. Must be low. Again, it's on the emitter, low. This one has how many nicknames? Two. What's one nickname? Emitter. Hey, oh, okay. Signal follows the emitter. Emitter follower. What else? Or the impedance or Z matcher. Again, this is the configuration. You can have a bunch of common emitter amplifiers cascaded together. Throw one of those on the end and attach it to a speaker. Matches impedance to the load, which is a speaker, so it's very good for that. There's the chart. Live it, love it, know it. Questions on the chart for the common amplifiers? Let's point out some similarities and differences to help you out. Well, one of the rules I keep harping about is whenever you're dealing with the emitter, it's always going to be low, isn't it? Look, current gain. Well, in this case, that's because 95%, but the impedance, inputs on the emitter, low. What else about the emitter? Well, that's common, so I can't really do anything about that because I don't have an input or an output directly to that. Over here, the voltage gain. Oh, it's low. It's on the emitter. The output impedance. Oh, it's at the emitter. It's low again. Does that make sense? Whenever you're dealing with the emitter, it's always going to be low. Whenever the input is on the base, or whenever you're dealing with the base, guess what? Oh, let's see. Common emitter. Input impedance. Yeah. So the freaking door. Okay. Inputs on the base. Look, high for common emitter. Inputs on the base for common collector. Guess what? There. Hello, fella. Guess what? High! These things make sense?
Yes, sir.
And guess what? If we know that everything in the common emitter is high, everything's high, isn't it? 180 degrees, high. Bam! If we know the common base, we know the common collector. You know why? Look, phase relationship's the same. The current gain for common base is low. The current gain for common collector is what? High. The voltage gain for common base is what? High. The current, or voltage gain for common collector is what? Low. The power gains are both high. Input impedance, common base is?
Low.
Common collector, it's?
High.
Output impedance on common base is?
High.
Output impedance on common collector is?
Low.
Holy crap, they're the opposite, except for power. That'll help you out a whole bunch, won't it?
Yes, sir.
Yeah. And I also told you during the lessons, hey, either analyze the circuits like I described, why, for example, current gain is low for common base. Told you the why behind it. Told you the why behind all these. So it's either that, or you just memorize the chart. We got two choices. So I gave you both. I gave you the theory behind why this is so, and also helping you out by look, hey, look, compare them. Look at the similarities and differences. Are we done with the chart?
Yes, sir.
Yeah, I know it.